Hello, this is Satbir. In this video, the topic of our discussion is the derivative of trigonometric function. We have six trigonometric function: cosine x, sine x, tangent, cot, secant, and consecant x. In this video, we will learn that how to compute the derivative of all these six trigonometric function, and also some examples of elementary function which are made of these trigonometric function. So here is the information you need to know in order to calculate the derivative of all six trigonometric function. The first one is the derivative of sine x is cosine x, and the second information is the derivative of cosine x is negative sine x. So here to be noticed that the derivative of cosine is a negative sine x. Using this information and also some trigonometric identities, we can calculate the derivative of the all rest of four trigonometric function. I will begin from tangent x. Let's start this problem. So we know that the tangent of x is a quotient function of sine x is in the numerator and the cosine x is in the denominator. So since this is a quotient function, we should use the quotient rule to calculate the derivative of tangent x. So cosine x sine x divided by cosine x, and we learned the quotient rule in the previous video. So how the quotient rule work? You take the derivative of the top, which is sine x. Derivative of sine x is cosine of x, and the derivative of cosine x is negative sine x. So do not forget a negative sign. So this is a negative sine x. And then we read that poem says a low d high. We will multiply low to high, which is a cosine x. So you go from low to high, which is a cosine x also. Derivative of high is cosine of x. And you put a negative sign and you reverse back high to low, which is a sine x time minus sine x. And divide by low, which is cosine of x. Cosine of x, the square of that whole entire thing. Okay, so this is the quotient rule, and what we do is we simplify a little bit. So this is the cosine x. This will become cosine square x, and this is a minus sign, minus plus. This becomes sine square x, and whole thing is divided by cosine of x, the square of that. And we know that we have one more trigonometric identity. The cosine square sine square x is 1. So this is equal to 1. So this quotient will become 1 over cosine of x square of that, or it's the same as 1 over cosine of x, the square of that. And another trigonometric identity, we know that 1 over cosine of x is secant x. So this will become secant square of x. That is our final answer. So the derivative of tangent is secant square x. So as you can see, using the two trigonometric identity, cosine square x plus sine square x is equal to 1, and 1 over cosine is equal to secant, we can find the formula of tangent derivative of the tangent x, just the information from the derivative of sine x and derivative of cosine of x. So similarly, I will show you this one more time. So we have tangent x, which is sine x divided by cosine x. We're gonna use the quotient rule, which is high d low minus low d high. So this is a high d low minus low d high divided by low square. Then I simplify the top. It becomes cosine square plus sine square divided by cosine square. Since cosine square plus sine square is 1, so this will give me 1 over cosine square, and this is nothing but is equal to secant square x. So that gives us the derivative of tangent is equal to secant square x. Now we can similarly calculate the derivative of cot by using the trigonometric identity. Cot is cosine x divided by sine x. And similarly, secant x 1 over cosine x, cosecant x is a 1 over sine x. By using these trigonometric identity with the quotient rule, we can calculate the derivative of all of these. So here, what we have here, the derivative of tangent is a secant square x, derivative of cot is a minus cosecant square x, you can verify that. And derivative of secant is secant x times tangent x, and derivative of secant is minus cosecant x times cot x. We will also try to remember all the 6 trigonometric derivatives for a faster calculation. Let's go to the next slide. I have more problems. I have 6 more problems you can do. I will work on the problem number 1. And I will work also on the problem number, not 6, because we have already done the 6, number 2. So I will work on 1 and 2. You can try the rest of the 4 problems by yourself. Okay, let's start with the problem number 1. So in the problem number 1, the function is sine x cosine x. So as you can see, this is a product of 2 function. F of x is, so this is the product of sine x and cosine x. So we will use the product rule. What is a product rule? The product rule is fx times gx. The derivative of the product is f prime x gx function as it is, and then plus sine fx derivative of g prime of x. This is the product rule. So let's start with this. So derivative of f prime of x. So that will be the derivative of the first function dy by dx of sine x time the second function is as it is, cosine of x is as it is, plus sine of x is as it is, and derivative of the second function dy by dx of cosine of x. So next is we will use the derivative. What is the derivative of cosine x, and what is the derivative of sine x, and what is the derivative of cosine of x? Derivative of sine x is a cosine of x. So this is time cosine of x, and plus sine x. The derivative of cosine x is minus sine x. It has a negative sign times. So therefore, this becomes cosine square x minus sine square x. So that's your answer for this problem is cosine x square sine square x. Similarly, you can do the next problem, which is the problem number 2 we're gonna do. So let me clear the problem first. So let's do the problem number 2 now. Our function is f of x is equal to 2x square plus 1 time cosecant of x. So this is again the product of 2 function, product of 2x square plus 1 and the cosecant x. So we need to know what is the derivative of cosecant x is, which we have seen in some previous slides. Let's go back. The derivative of cosecant x is minus cosecant x into cot x. So this information we need to calculate the derivative of the this function. So first, let me write down the formula f prime of x. Since this is a product rule, so let's write down the product rules. The derivative of the first function is 2x squared plus 1 is our first function. And secant x is as it is, and then plus 2x squared plus 1 is as it is, and we will multiply this to the derivative of cosecant x. So derivative of 2x squared plus 1 is 4x, and derivative of cosecant of x is, the cosecant is as it is, and then 2x squared plus 1 as it is, and derivative of cosecant x in the previous slide is minus cosecant x plus cot x. So it's going to be minus cosecant x times cot x. So this is the final solution. You do not have to simplify, but if you would like, you can. So here I give you the solution of problem number 1 and 2. You can pause the video here and solve the rest of the 4 problem by yourself. If you have any question, you can leave in the comment section below. Here I have one more example to practice this rule on. So here I'm asking to calculate the second order derivative of the function tangent x. So let's do how to do that one. So the solution. So we need to compute the first order derivative f of x. First order is dy by dx of tangent x, which we have seen in a few minutes ago. The derivative of secant x was, the tangent x was secant square x, which can also be written as secant x times secant x. The square of secant x is secant x times secant x, which can also be written as secant x times secant x. Now, this is the product of secant x function to itself. So now I want to compute one more order derivative of that function, the second order derivative of the function. Second order derivative is the one more derivative of the first order. So it will be the dy by dx of this function, secant x times secant x. So since this is the product of two functions, I will use the product rule. So what is the product rule? The derivative of the first function, which is a secant x. The second function is as it is. I will just write the secant x, repeat it, and then I put the plus sign. I will have the first function as it is and the derivative of the dy by dx of secant x. The derivative of secant x dy by dx of secant x. So as we know from the few slides back, the derivative secant x is secant x times tangent x. So dy by dx of secant x, we have formula. This is the secant x times tangent x. So we'll use that here. So it's going to be a secant x times tangent x times secant x. And then this is a plus secant x times secant x and tangent x, which will be, if I get more space here, which will be, it's going to be a 2 times of secant square x times tangent x. So this is the second order derivative of our function. So this is my solution to that problem. So now I have few more problems for you to practice. My first iClicker question is, what is the fourth order derivative of the function cosine of x? So pause the video for 1 or 2 minutes and practice on this question. If you have any question, you can ask me in the comment section below. And then I have another iClicker question, which is I'm asking to what is the 30th order derivative of sine of x. Again, if you have any questions, you can always leave me in the comment section below. This is our last problem. What is the derivative of, so here the question is one of the application of the derivative of trigonometric function in which we ask you to find the tangent line. So what is the tangent line on the graph of this function, which is a 2x times sine x at this point? So we have given the point. The point is given, solution. The point is given. So we have to find the equation of a line passing through this point, pi divided by 2 comma pi, on the graph of that function, y is equal to 2x sine x. So what we need to do is first we need to find what is the slope of that tangent line. So first we will calculate the slope. So again, calculating the slope is basically calculating the derivative of this function. So I will calculate f prime of x. If my f of x is the given function 2 sine x, and the derivative is again is a product rule because this is the product of two functions. I'm going to calculate dy by dx of the first function, derivative of the first function, second function as it is, sine of x as it is, plus function as it is times the derivative of the second function, which is a sine x. So derivative of 2x is just 2 times sine x plus 2x derivative of sine is cosine of x. Now the slope is, so the slope will be the value of the derivative evaluated at pi by 2. So when you plug the x value of the point into the derivative, that gives you the slope of the tangent line. So if I plug here, this is going to be a 2 sine pi by 2. And this is going to be a 2 times pi by 2 times cosine of pi by 2. So here, if you simplify this one, we are going to get 2 times sine pi by 2 is 1. So this is going to be a 2. And but however, cosine of pi by 2 is 0. So it's going to be 2 plus 0. That's just 2. Now we will find what is the equation of the line. So let me turn that page blue. So we have the slope. The slope of the function is 2, and the point is pi by 2 comma pi. So we need to find the equation of the line which passes through this point which having the slope 2. So we know that the equation of the line is mx plus b, where y is equal to m is a 2x plus b. Since that line passes through this point, so we can plug that point into this line. So y value is a pi when x value is pi by 2 plus b, and therefore pi is equal to pi plus b. This implies b is equal to 0. Therefore, this gives you y is equal to 2x plus 0. So that's the equation of the line, y is equal to 2x. So that's in the today lecture. on the derivative of the trigonometric function. Bye for now.